are Sanapi Biomedical. We are a disposable medical device manufacturer that specializes in chest drainage. This usually involves getting excess fluid or air out of the chest cavity that shouldn't be there. This is usually the cavity between the lungs and the rib cage. Our main product is the chest drain. As you can see here, this is a mechanical version we've developed. We focus on cost saving for the device, but recently we have moved to a more electronic version. This is to kind of give doctors more insight into what is happening with the patient. This could be from getting a better idea of the pressures that the patient's experiencing, or the amount of fluids or air that is actually being evacuated from the patient, so the doctors can make a more informed decision on what treatment needs to be given to the patient, or if the treatment for the patient can be ended. So our part of how we measure the, oh, sorry, I'm just going to scratch that. Part of the main feature for the digital device is the liquid drainage. It is very important for the doctors to see what fluids have been drained, as well as how much, because this is a very big indicator of whether or not the patient is actually improving. Part of how we achieve this is through a custom vision system that we have developed. ANSYS assisted us with developing the system by allowing us to simulate actually what we would see inside the device. So we could gave them the conditions the device would be operating in. So that's the ambient light, type of lights we're going to be using, the camera setup that we want to use, and this allowed ANSYS to appropriately simulate a base model for us, which we then took a bit further with ANSYS obviously assisting us throughout that process. It actually gave us quite insightful information because it confirmed some of the things we already knew, as well as showing us potential drawbacks that could come from the design, and from these drawbacks obviously we could then develop it further. So part of the building, part of the development phase for the simulations, it was needed by ANSYS to give us the appropriate training. This was done quite well through giving almost practice exercises for us to do that relates to the project we wanted, the project that we were working on. Then there would be almost weekly touch bases to see how we were progressing with that. Any issues that were kind of brought up, ANSYS assisted us to show us how we could improve the simulation, or potentially what was being done incorrectly, so that we could get the correct results that we wanted. The software that was used was actually very how can I say, it was actually very powerful software. You kind of could tell it exactly what it is you needed, and it was able to run those simulations. It would accommodate for the ambient light, the wavelengths of the light you're using. It even accommodates for the various materials that were being used, as this allowed us to also see what materials would actually be useful in the device and what materials would not. And this was, again, it's allowed us to develop quite quickly and easily, because it eliminated the costs of iterating, as you could do it all on the computer without actually having to go and buy and mold various devices and various components. As well as it also kind of preps you for what you'd see when you actually go ahead and do the physical testing. As like I said before, a lot of our results lined up quite closely with what was shown in the simulations. So therefore, that kind of sped up prototyping time is we kind of already knew what to expect. The software itself, it was after the being instructed on how to use it, was actually quite straightforward to use. There was nothing was hidden, if I could say that. Everything, if you were looking for this feature, it was kind of where you would expect it to be. It wasn't in a little funny hidden menu that you had to go digging for to find. As well as the software for what for what it was doing. It was surprisingly, yes, there are times where it would be quite intense on the computer, but for most of the time, it was actually surprising how not resource hungry it was, if I can put it like that. I was able to run it on your kind of just above average laptop without any issues. But obviously now, as with any simulation software, during simulation time, when you're simulating it, kind of just leave the PC, but that is definitely as expected. I was still able to actually do work while it was simulating. Um, but yeah, it was actually very handy to have. Like I said, it cut prototyping time down quite a bit and was actually able to allow us to see what we were going. I almost want to say it allowed us to see what we were going to see through our tests without actually having to manually build the prototypes and make the components as such. Um, yeah, that's kind of all I have to add.